Lopes, and this is my Artefact presentation on the research criteria for Internet service provision and procurement for the Government of Guyana's ministries and agencies. Okay, so identifying the cybersecurity requirements for ISP provision and procurement. One, we need to evaluate the current method of ISP procurement. To identify the cybersecurity considerations within the procurement method, develop a standard for procurement, and lastly, understand the criteria to be met before commercial ISP services can be provisioned, aiding in the evaluation of ISPs. So this is the current method of procurement where a government agency expresses its need for an ISP service. The request is based on availability, price, services, whether it be they want a public IP address or VoIP landline services, and bandwidth. So after this, the memo is created to request purchase. The decision is made whether yes to approve this memo. If approved, the memo is forwarded and then a payment request is made. After that payment is made to the ISP and payment is received, they provide relevant documentation such as the receipt, the SLA agreement, and then you await the installation based on the period that the ISP has indicated. So this is a conceptual model for the stakeholder-driven evaluation model. The first step is to select the data collection tool. The data is then collected, the data after which is analyzed, the model is developed, validation of the model is done, then there's the refinement and finalization and documentation and dissemination of the model. Here we have the conceptual fuzzy model. My approach to assessing the cybersecurity threats for ISP procurement, the security score fuzzy model, as this is being coined. This model leverages the fuzzy logic to provide a sophisticated, nuanced assessment of cybersecurity threats, thereby enhancing our decision-making process. So step one is to define the inputs. The first input would be the cybersecurity threat indicators, identifying the key indicators that affect ISP security. Examples might include the frequency of attacks, types of cyber attacks, whether it be DDoS, phishing, malware. Now, I would have received logs from the National Data Management Authority on the threats received based on the public IP addresses assigned to these ISPs. And going on in the presentation, these ISPs would be, a sample would have been done from the analysis, and they will be represented very vaguely. For example, commercial X, ISP X, Y, Z. Another thing we would take into consideration within the definition of the inputs would be the stakeholders' concern, including inputs from stakeholders regarding their perception of ISP security, which can be gathered through the surveys and interviews. Secondly, we have to define the membership function. Establishing the membership function, first we need to, for each input variable, create a membership function that defines how each term, for example, high, medium, low, is represented. For instance, the frequency of attacks. Is the frequency of attacks from 0 to 10 considered low, 11 to 50 considered medium, etc. The severity of attacks. Low can be due to minor disruption, medium where moderate data services lost, and high where significant data and services are lost. And then the scale of the definition, ensuring all membership functions are scaled appropriately to reflect the actual conditions and data observed within Guyana. There we need to develop fuzzy rules. where the rule creation constructs a set of fuzzy rules that describe how the input variables interact to affect the overall threat level. Example of these rules could include if the frequency of attacks is high and severity of the attacks is high, that threat level is very high. Or if the stakeholder concerns are high and the frequency of attacks is medium, that threat level is high, just high. Uh, the fourth step, we need to apply the fuzzy inference system, where we choose the inference system uh, by selecting a fuzzy inference system type, such as the Mamdani or Sugino, that best suits this data and the objective of the research. And then we need to process the inputs, input the data in the fuzzy inference system, which applies the rules to input the process rules to input and processes them through the membership functions. And then we have the defuzzification, where we convert the output using the defuzzification method to convert the fuzzy output set into a single number of crisp values that represents the overall threat level of an ISP or the ISP security score. The common defuzzification method includes the centroid, the bisector, and the mean of maximum. And then we have the visualization. The method of visualization will be in the form of a threat map. The threat map visualization shows the resulting threat levels on some kind of map of Ghana, showing the different regions or points which ISPs operate to depict geographical variations in threat exposure. Step 6, we have to test the model through validation and collaboration to validate the model with actual data and expert reviews to ensure it is accurately reflects the cybersecurity threat landscape of Guyana. Calibrated as needed, where we adjust the membership function rules or the inference system based on the feedback and new data to improve the accuracy and relevance. And then to lastly integrate and report the findings. We integrate the model and incorporate the fuzzy model into the broader stakeholder-driven evaluation framework for the ISP procurement. Report and findings where we document the model development, the implementation details, and findings of the research topic, providing insights into how the fuzzy logic can enhance the cybersecurity threat assessment. So here we have a sample of the threat map visualization concept, where we can see on the left an ISP security score. We have ISP W, X, Y, and Z. And below it we have a little detail of the evaluation, when the evaluation was last done, the status of the evaluation, and who the evaluator was. On the map, we just have a representation of Guyana and where that traffic would have been disseminated from. Alright, and after the model has been implemented, this is the proposed procurement method, where now we have the ISP security report as a criteria now before services can be requested. Now we'll talk about the limitations. So based on the previous methodology presentation, we learned that, well, it was indicated to you that the limitations of this project would be the sample representation, the subjectivity in the qualitative analysis, the response bias, and the external validity, as well as the resource constraints. But we need to also consider, well, one, the ISP coverage area. Now, the ISPs, yes, you might have ISPs that might not pass but they might be the only ISP available in a specific region. For example, you can see here on the map, there's just a concept where you would see the ISPs in the different regions and whether or not they are available. And then there's the risk score indicating that some ISPs might not pass, but they're the only option. Then does the agency go without internet services just because it's not available? So that's one of the limitations. Second one is lack of policies. Now, these ISPs are not mandated, or there's no law that makes them have to be evaluated or have to go through any type of risk assessment to contribute to the criteria to be met. However, by implementing this criteria within the procurement process of the government agencies, we are making the selection solely internally, where eventually it will trickle down to the ISPs, where in order for them to be selected, they would feel as though they have to comply to certain security regulations. And that is the end of my presentation. Thank you.